So good morning to all of you MSc first year physics student. So today again welcome to lecture series in our subject in quantum mechanics, and we want to continue our chapter is the angular momentum, and we want to see today the point that is the general formulation of angular momentum. And in this point we want to see the general formalism of angular momentum of orbital angular momentum for rising and lowering operator, this L plus and L minus. And again we want to see the general formalism of total angular momentum, so that is J plus and J minus. So you know that this L plus cap, this operator, rising operator, is nothing but the Lx cap plus ILy, and L minus cap of Lx minus ILy. And this rising operator value, so that is the operates on the orbital angular momentum and spin, so that ms value which is considered as minus L2 plus L. So this is L comma m is equal to some constant c value, so that is normalization constant value or generally constant value. And if this L plus which is operates on this m, so this L is as it is, and this m L plus operates on this m, so this get m plus 1. And again see this L minus get of L comma m, this L minus which is operates on this m, so we have to get value some constant c, or this L minus operates on m, so this is the m minus 1. Okay, and this is the Kate relation. So in general formalism of or the notification of or solve the wave function. So for example, the wave function of psi, which is denoted as like this, so that some constant c value, or which is the bra of psi. Okay, so this is the bra notation. And again this wave function, that complex conjugate of this, if you see, so that wave function again represented as some constant c value and Kate of this psi. Okay, so this using of this bra and Kate relation, we want to solve this rising and lowering operator, and how it is get solved, and we want to solve what is the expectation value of Lx, L plus, Lz, L square, and L minus so on. We have to calculate using of this idea. Okay, if we see, for example, consider for the p state electron. Okay, you know that idea. For p state electron, so that is the p orbital electron, and angular momentum, orbital angular momentum value, so that is small l is equal to 1. And you know that if small l is equal to 1, this value ms is running from minus 1 to plus 1, or plus 1 to minus 1. So that is for ms is equal to 1 0 minus 1. Okay, and depending on this, so that the state which is arise here, so that is the L comma m. Okay, this value is nothing but the state which is considered as the relation L and m, which is this 1 and 1, so that is 1 comma 1, again 1 comma 0, and again 1 comma minus 1. Okay, and this is the highest state of the this configuration, and this is the lowest state. And using of this, we want to see the matrix representation of the Pauli spin matrices and total angular momentum. Okay, and if we see here, so that is the L cap plus of the highest state, the highest state is equal to 0. So that is mean what? So that L plus comma L comma ms or L comma L, so that is also 0. So that is L plus of L comma L is equal to 0. And for example, if we consider the L plus of acting on 2 minus 2, so that is equal to 0. Okay, and again we have to see that L minus which is considered here, so that is the for the lowest state. Is equal to 0. Okay, so that is L minus of L comma L is equal to 0. And for example, okay, so L minus of 2 comma minus 2, 2 comma of minus 2, so this is equal to 0. Okay, first of all we want to consider see the general idea, and again we want to solve this bra and cat relation. So for example, you know that this L plus is nothing but the Lx plus ILy, okay, and L minus is nothing but the Lx minus ILy, okay. And if we doing addition of this angular momentum, so addition of rising and lowering operator, so that is L plus and L minus. So direct we have see here, so that is the addition here. So L plus plus L minus is nothing but the twice Lx minus this plus ILy, and minus ILy is 0. So that's why the Lx value is nothing but the 1 by 2 L plus and L minus, 1 by 2 L plus and L minus. And if you solve this L plus L minus bracket, so we have to get the eigenvalue relation of this. So how this L plus value is 0, okay. And again see this the subtraction of this L plus and L minus. So this L plus is nothing but the Lx minus ILy, and this L minus is nothing but the Lx minus ILy. And if we doing subtraction of these, okay, so what happens? So this L plus minus L minus is equal to 0 plus twice ILy, and therefore the Ly value is nothing but the 1 upon twice I in bracket of L plus minus L minus, okay. So these two result which is obtained in front of you. And if we solve the expectation value relation of this, okay, so first of all we have to need find out the L plus and L minus operator value. So again see here, okay, so we have to know that, so that the L plus of L comma m, this operator which is nothing but the some constant c, and the value which is considered as the L comma m plus 1, L comma m plus 1. And if we taking the complex conjugate of this relation, okay, complex conjugate of this. So this is nothing but the L comma M, or which is minus L minus C star. Okay, so complex conjugate of this, so this is nothing but the L comma M. Okay, this L minus, and this is nothing but the complex conjugate of this, so that is the C star. So this complex value, and this is nothing but the bra of L comma M plus 1. Okay, and if you take the linear combination of this solution, okay, linear combination of this solution, so what you obtain here, so that is the this bra of L comma M, bra of L comma M, L minus L plus, okay, of L comma M is nothing but what happens here. So this L comma M, okay, L plus and this, so this L comma M, L plus and L minus, so that value will get, so that is the mod of C square L comma M plus 1 and L comma M plus 1. So this, okay, so that is, okay, so that C star and this C, so that is considered as the mod of C square, or if we write here, so this is mod of C square, this L comma M plus 1, and this linear combination with this L comma M plus 1. Okay, and if you know that L comma M plus 1, L comma M plus 1, so this is the by the orthonormalization condition, so this is get is 1. So this bracket which is considered as L comma M, L minus and L plus, this L comma M is nothing but the mod of C square. Okay, and we want to solve this value. So what is the value of this constant? So mod of C square, and how it is calculate. So this mod of C square is nothing but, okay, so that the expectation value of this L minus and L plus, okay, expectation value of L minus and L plus, and this expectation value we have to know that calculate in the last lecture. So that is Lx minus ILy and Lx plus ILy, and multiplication of this, so we have to get direct value, so that is the Lx square plus Ly square minus h cross of Lz, minus h cross of Lz, and if we solve, so that value which is nothing but, so this Lx square plus Ly square, you know that the L square is nothing but the Lx square plus Ly square plus Lz square. Okay, and if you see here, so Lx square plus Ly square minus Lz square is not there, so Lz square is what? So L square, so Lx square plus Ly square is L square minus Lz square, so that is the Lx square plus Ly square is nothing but the L square minus Lz square. Okay, and if we put this value in this equation, so this is nothing but the L square minus Lz square minus h cross of Lz. Okay, and you know that the expectation value of your L square is nothing but the h cross square L into L plus 1. Now first identity, so that is the expectation value of L square is nothing but the h cross square L into L plus 1. Expectation value of this Lz square is nothing but the minus m square h cross square, or which is considered as h cross square m square, and expectation value of Lz, which is the minus h cross of m. Okay, and by putting this value in this equation, so by using this, so this relation will become here, so that is the h cross square, okay, expectation of L square minus expectation of Lz square and minus h cross of expectation of Lz. Okay, so this is nothing but the h cross square L into L plus 1 minus h cross square m square and minus h cross into minus h cross and m. Okay, here h cross square m square, and here minus minus plus, so that is the h cross square m, and if we taken out h cross square m, so if we taken the common of this, so that your final relation will be obtained here, so that is the h cross square L into L plus 1 minus m is taken common outside, so minus m into m plus 1. So this is the value of mod c square, and if we calculate the value of only c, if we calculate the value of c, so this is nothing but the h cross square L into L plus 1 minus m into m plus 1 minus m into m plus 1, and this value will get here. Okay, so that is, and if we put this value in, L plus of comma L comma m is nothing but the h cross of under root of L into L plus 1 minus m into m plus 1, and the relation will be take, so that is the L comma m plus 1. So this is the relation for way of getting the value of L plus operator, the relation getting from the value of L plus operator, and we want to again the calculate the value of L minus of L comma m, and this you know that, so that value which is nothing but the some constant c of L comma m minus 1, and what is the value of this we want to calculate. So how it is calculate this value? Okay, again we want to calculate this relation. Okay, and if we take the complex conjugate of this L minus of ket of L minus 1, which is nothing but the L comma m, so taking the complex conjugate of it. Okay, and this complex conjugate is nothing but the L comma m of L plus is nothing but the c star of this L comma m minus 1. Okay, and if you take the linear combination relation of this. So this value is nothing but the ket relation of this. So that is the L comma m of L plus and L minus of L comma m is nothing but the mod of c square in bracket of the value L plus and L minus. Oh, sorry, this is the L comma m minus 1 and L comma m minus 1, and you know that the orthonormalization condition, so this value is get 1. So we want to calculate this mod of c square, and this is nothing but the L plus and L minus, and this is nothing but the expectation value of Lx square plus Ly square minus plus this h cross of Lz plus h cross of Lz, and you know that Lx square plus Ly square is nothing but the L square minus Lz square. So this is the L square minus Lz square plus h cross of Lz. Okay, and you know that this relation, so L square, so expectation of L square minus expectation of Lz square and plus h cross of expectation of Lz. This expectation of this L square is nothing but the h cross square L into L plus 1. This is minus h cross square m square and plus h cross into minus h cross of m. And if we taken common of this, so this h cross square L into L plus 1 minus m into m minus 1. So this is the value of mod of c square, and the c value is nothing but the h cross into under root of L into L plus 1 minus m into m minus 1. Okay, and if we putting this value is here, so the relation which is obtained, so what is relation is there? So L minus is nothing but the L comma m is equal to c into some constant L comma m minus 1 ket relation, and this c value is nothing but this. So this L minus is nothing but the L comma m, and this c value is nothing but the h cross under root of L into L plus 1 minus m into m minus 1, and this relation will be take with respect to ket relation of L comma m minus 1. So this is the actually value of the rising and lowering operator. Okay, and again in the next lecture we want to see this expectation value of and the general formalism of angular momentum of total angular momentum, general formalism of total angular momentum, and this point we want to see in the next lecture. So thanking of you.